Introduction to AC. AC stands for alternating current. The AC power source produces potential that varies with time. Creation of AC waves. The electromechanical alternator produces voltage which switches polarity after fixed intervals of time. When it is represented on a graph, it looks like a sine wave. Concept of frequency and period. The horizontal axis of the graph representing AC waves is marked with time, and the dimension marked with one cycle of time is measured as period. Another measurement that can be taken is a back and forth oscillation of the wave, called frequency. Period and frequency are mathematical reciprocals of each other. Measuring AC voltage and current. AC voltage alters in polarity and current alters in phase. Hence, the peak of the amplitude of the wave is considered and the peak-to-peak value is taken. Resistance in AC circuit. In a circuit consisting of AC generator and resistor, the output of AC source varies with time. It is calculated using the formula V equals Vmax into sine of 2 pi ft. From the sine wave shown, it can be seen that voltage and current are in phase. RMS values. To calculate current and voltage values when they change with time, RMS, root mean square values are adopted. Capacitance in AC circuit. From the diagram, we see that the capacitor is connected directly across a power supply. As the voltage increases or decreases, the capacitor charges or discharges. From the phase diagram, we can see that the current leads the voltage by 90 degrees. Inductance in AC circuit. The circuit consists of an inductor coil across a sinusoidal power supply. The current flowing in the circuit would cause the inductor to induce a magnetic field which would oppose any change in the current. From the phase diagram, we can see that the voltage leads the current by 90 degrees. Energy in AC circuit. The presence of either the resistors, capacitors, and inductors in each circuit differs the functioning of the circuit because each component behaves differently with the electrical energy stored. Resistors dissipate power as heat. Capacitors store electrical energy and give it back, and no energy is lost. Inductors store energy in their magnetic field and give it back, and again, no energy is lost. RC circuit. It is also known as RC filter and RC network. It is composed of resistors and capacitors driven by a voltage or current source. A simple RC circuit consists of one resistor and one capacitor, either in series or in parallel to each other. In both RC series circuit and parallel circuit, capacitor discharges its stored energy through the resistor. This RC circuit is more commonly used as filters since capacitors are small and easy to manufacture. RC series circuit. It is the simplest circuit where a capacitor discharges through the resistor connected in series to it. Voltage across RC series circuit. Voltage is calculated using Kirchhoff's law. RC parallel circuit. Here the output voltage is equal to the input voltage. Hence a capacitor connected in parallel to the resistor is not useful. Here V out equals V in. RL circuit. RL circuit, also known as RL filter, is an analog infinite impulse response electronic filter. In this circuit, resistors and inductors are connected either in series or parallel, which is driven by a voltage source. RL series filter working. When an inductor is connected in series with resistor and a constant voltage flows through it, a step response input is generated, and due to the induced EMF, induced current is reduced to zero. RL parallel circuit working. When a resistor and inductor are connected in parallel with each other and input voltage is supplied, the input and output current is different across resistor and inductor, but the input and output voltages are same. RL filter applications. RL circuits are used for DC power supplies to RF amplifiers. Voltage in RL circuit. Voltage in RL circuit is given by total voltage equals voltage across resistor plus voltage across inductor. Total voltage is given by the expression seen on the screen. LC circuit. LC circuits are also known as resonant circuits Tank circuits or tuned circuits. This circuit acts as an electric resonator, storing energy oscillating at the circuits. Concept of resonance. When the inductive and capacitive resistance are of equal magnitude, the resonance effect occurs. LC filter resonant frequency. The resonant frequency of LC circuit can be calculated using this formula. Omega equals 1 by square root LC. LC filter. The capacitor in the LC circuit stores energy in the electric field, E, between the plates depending upon the voltage across it, and the inductor stores energy in its magnetic field, B, depending on the current through it. Series LC circuit. In this circuit, the inductor and capacitor are connected in series with each other, and the total voltage is voltage across inductor plus voltage across capacitor. Parallel LC circuit. The inductor is connected in parallel to the capacitor. The total current in the circuit is current across inductor plus current across capacitor. LC filter applications used in oscillators, filters, tuners, frequency mixers, induction heating. RLC circuit. The RLC circuit consists of resistors, inductors and capacitors either in series or in parallel. The working of RLC circuit is similar to LC circuit, but the presence of resistor enables the oscillation generator to die over a period of time if not activated by an external source. RLC circuit damping. Damping is caused by the resistance in the circuit. It determines whether the circuit would resonate naturally or not without any source. Damping factor is given by zeta. RLC circuit resonance. Energy is stored in the circuit in two different ways: electric field by capacitor and magnetic field by inductor, and due to this, resonance occurs. The resonant frequency F0 and angular frequency omega 0 is given as shown. RLC circuit natural frequency. The natural frequency is the frequency of the oscillations that take place even after the driving source has been removed. The natural frequency is given by omega 0. RLC circuit bandwidth. The frequency at which the power is passed through the circuit falls to half of the value at resonance is the bandwidth. The difference between the two half-power frequencies is shown. RLC circuit Q factor. It is the peak energy stored in the circuit and is used to characterize resonators. Q factor is the inverse of bandwidth and is shown as RLC circuit scaled parameters. All the circuits with the above parameters have similar characteristics even when they operate on different frequency bands. Series RLC. All the three components, resistor, inductor and capacitor, are connected in series to each other. The current across each of these components is same, but voltage gets divided. Parallel RLC. All the three components, resistor, inductor and capacitor, are connected in parallel to each other. The voltage across each of these components is same, but current gets divided. Comparison between series RLC and parallel RLC. A series RLC circuit can be analyzed with the following factors: voltage, resistance, reactance, and impedance, whereas a parallel circuit is opposite to it and can be analyzed with its respective reciprocals like admittance, conductance, and susceptance. RLC applications. RLC circuits are used for tuning in analog circuits as low-pass filters.